Welcome to my channel Jee-Advance physics classes. Let us discuss a very important problem. The problem is a water droplet is placed in the field of a point charge Q. How far from the droplet must the charge be for the electric forces to overcome the force of gravity? The radius of the droplet is much less than the distance between droplet and the charge. Given dielectric constant of water is K, density of water is rho. So numerical values are not given. Let us discuss. Now, a charged particle Q produces an electric field. Now, in the electric field of this charge, we have a water droplet. Now, we have to find out what is the distance so that the electric force or electrostatic force exerted by the charge Q on this water droplet will overcome the force of gravity. Now, the gravity is downward mg, that is, if volume is V, density rho, then this is the weight acting on the water droplet downward. Now, how do we expect that this charge will exert an electrostatic force acting in upward direction? Now, this charge produces a non-uniform field, and in the non-uniform field of the charge plus Q, the water droplet is there. Now, water molecule is polar molecule, that is, each molecule is an electric dipole. Now, this dipole will be oriented along the direction of electric field. That is, if this is the direction of the electric field, the dipoles are oriented, that is, the dipole moment vectors are along the direction of electric field. So, the dipoles are oriented and aligned along the direction of field, and this phenomenon is called polarization. That is, in the presence of electric field, a dielectric medium is polarized. Whether it is permanent, it has permanent dipole moment or not. Now, water molecule has permanent electric dipole moment and they are aligned along the direction of electric field. As a result, an electrostatic force is exerted on the water droplet, and we want that what should be the distance between the charge and the water droplet. Here, we assume that the radius of this water droplet is very small in comparison with or in comparison to the distance between the charge and water droplet. Now, how to solve? All the derivations now I will do, then only to understand the physical basis of the problem. But this problem will be solved only in 3 steps, provided you know the working formula. So let us derive the working formula. Now, we know electric dipole experiences a force in electric field, in non-uniform electric field. Now, what is this force? We shall find out. Now, since the water droplet is polarized, the polarization vector is equal to vector sum of dipole moment, that is the total dipole moment for unit volume. Simply let us say that the polarization is total dipole moment for unit volume. Now dipole moment is equal to polarization into volume. This is equation 1. Now let us see how to find out a force acting on the dipole molecule. Now this is in a non-uniform electric field, as the case is here. This is the dipole moment or electric dipole, say negative charge minus Q here, positive charge plus Q here. Now only in the presence of uniform electric field, the force exerted on the charge minus Q is equal to the force exerted on the charge plus Q, and both are in opposite sense, and the total force is 0. But it is a non-uniform field. Let ER be the field or intensity of electric field at the charge minus Q, and if L is the length of the dipole, then E R plus L will be the field at point plus Q. So ER plus L is different from ER. So how to evaluate ER plus L? The electric field is a continuous function. ER plus L is equal to, it can be expanded in terms of electric field at position of minus Q, that is at position R. This is ER plus L derivative, say total derivative I'm writing dE upon dr, derivative of electric field with respect to distance, plus some terms, higher powers of L and higher order derivatives of electric field. Since the length of the dipole is very small, here it is the molecular dimension, that is that of the length of the water molecule. So if L is a 0 of first order, L square is a 0 of second order, so all the higher order terms are neglected, and we have ER plus L dE by dr. As a result, the force, total force exerted on the dipole is equal to minus Q E plus Q multiplied by this factor, that is E plus Q L dE by dr. Now this gets cancelled. We have Q L dE by dr. One thing, QL is the electric dipole moment. This is P dE by dr. Now P is the dipole moment, which is Q into length of the dipole. Now another thing is that to make the magnitude of force positive, we have to either use a sign, negative sign here, because electric field decreases with distance. So the variation of electric field dE and dr are opposite sign. So either you introduce a minus sign here, or you take the magnitude. So let us take the magnitude of the force. So one working formula is dipole moment is polarization into volume. Second working formula is force equal to dipole moment dE by dr. Now I shall discuss the third working formula. So how to find out polarization? This is dipole moment. This I can write, it is equal to polarization volume V dE by dr. Now let us see how polarization is related to intensity of electric field. Now, how polarization is related to intensity of electric field produced by the charge Q. One thing we know Gauss law in presence of for electric field that surface integral, rather say this is the flux of electric field over a closed surface S is equal to 1 upon epsilon 0 summation of the charge Q or capital Q, whatever you write, say capital Q. Now, electric field relates to all the charges. All the charges means the free charges as well as bound charges. Bound charges means the charge appears on the surface of the dielectric because of polarization. So let us write this is equal to 1 by epsilon 0 summation of QF, F for free charges and QB for bound charges, that is due to polarization. Now multiplying epsilon 0 intensity E n cap integral ds is equal to QF free charge plus bound charge. Bound charge here I can write this is related to the polarization, flux of the polarization vector. How and why, this is very important, but time is not enough to discuss how. But we know that the electric field also results because of the polarization and the bound charges QB can be related to the polarization vector by the formula minus P dot n cap ds, or this we can write epsilon 0 E plus polarization vector dot n cap ds is free charge. This is a very important concept, that is electric displacement vector differential. This is the electric displacement vector d dot n cap ds is equal to free charges. The difference is that electric field intensity relates to free charge as well as bound charges, but electric displacement is related to only the free charges. So electric displacement epsilon 0 E plus polarization. Now polarization depends upon electric field as well as nature of medium, and we write epsilon 0 E susceptibility into electric field, or epsilon 0 susceptibility is an electrical property of the medium. So epsilon 0 plus xe, this is epsilon E, that is we write displacement equal to epsilon, that is the permittivity of the medium, into E. Now the question is, I write here epsilon 0 E plus polarization P equal to epsilon E. Now you express polarization in terms of electric field P equal to epsilon minus epsilon 0 into intensity of electric field. In the question it is given dielectric constant K is given, and you relate this is K epsilon 0 minus epsilon 0 into E. Now Hall working formula is our polarization relates to intensity of electric field, that is equal to K minus 1 epsilon 0 permittivity of free space into intensity of electric field. This is the electric field produced by this charge. So I can write that this force equal to, in place of polarization, this is K minus 1 epsilon 0 into intensity of electric field, K minus 1 epsilon 0 intensity of electric field into volume of the water droplet dE by dr. So this is our working formula. So if we know all these things, the problem will be solved only in 1 to 2 steps. This is very important for IIT entrance examination. Now see, intensity of electric field at a distance say r, separation between the charge Q and the ball say r, center from center of the water droplet to center of the conducting surface on which charge Q is there. And since this is very small, so distance can be taken equal to distance between the center of the surface on which the charges are distributed to the center of the water droplet. Now this force equal to K minus 1 epsilon 0, this is epsilon 0, intensity is Q by 4 pi epsilon 0 r square, K minus 1 epsilon 0 Q by 4 pi epsilon 0 r square, volume of the water droplet B, and differential of electric field Q by 4 pi epsilon 0 r square. This is equal to K minus 1 epsilon 0 Q into volume 4 pi epsilon 0 r square Q minus 2 4 pi epsilon 0 r cube. Derivative of 1 by r square is minus 2 1 by r cube. So this is taking the magnitude only, because I have already told you K minus 1. Here epsilon 0 got cancelled, Q square K minus 1 Q square into B, 2 got cancelled, we have 2 pi 8 4 pi 8 pi square, 2 into 4 pi 2 pi into 4 pi 8 pi square, epsilon 0 r to the power 5. Now we want that this force is due to electric field produced by the charge Q should be greater than or equal to mass into acceleration gravity, that is mass is volume, density mass into acceleration gravity. So this volume cancels. If the electric force is greater, it gets accelerated upward. But we want minimum value, that K minus 1 Q square 8 pi square epsilon 0 r to the power 5 equal to density into acceleration due to gravity. Now r to the power 5 equal to, we want distance, r to the power 5 equal to K minus 1 Q square by 8 pi square epsilon 0 rho into G. Again, r to the power 5 equal k minus 1 q square 8 pi square epsilon 0 rho g, or the separation should be k minus 1 equal to q square 8 pi square epsilon 0 rho g to the power 1 by 5. If distance between the charged particle and the water droplet equal to k minus 1 q square by 8 pi square epsilon 0 rho g to the power 1 by 5, then only the charge can be held at rest by the electrostatic force, because the electrostatic force becomes equal to the force of gravity. If the distance is decreased, electrostatic force will be more than that of gravity. In that case, the charged particle will accelerate. So the required expression for R is we obtain, provided if you know the value of K, charge numerical value for Q is given, density is given, and epsilon 0 you know, you can find out the value of the separation between the charge and the water droplet for the water droplet to remain stationary. This is very important question. It is lengthy because of the derivation part. Provided you know the working formula that dipole moment is polarization into volume, that force experienced by electric dipole equal to non-uniform electric field equal to P into dE by dr, P the dipole moment. For uniform electric field, this derivative becomes 0 because E is constant, so no force is exerted on the electric dipole. So P equal to PV dE by dr, and this is very important point, that polarization vector relates to intensity of electric field and dielectric constant. Now, with these three working formula, we can find out the expression for R. Thank you.